Okay, today we are starting a whole new chapter, and we're actually on a new GVC. So if you look up at, you're probably not in the classroom right now, but if you look at our GVCs, GVC 4 says I can use ratios, rates, and proportions to solve problems. So this whole chapter will be focusing on ratio, rates, and proportions, and how to use those to solve problems. Okay, so we have 4 vocabulary words up at the top. We're going to write those in our vocabulary, but we'll do short little definitions on this page so you remember. A rate or a ratio is a comparison of 2 quantities. Okay, so you're going to compare 2 quantities. I'm going to make sure I'm spelling quantities right. Okay, then you have a rate, and a rate is a ratio comparing 2 numbers measured in different units. A ratio comparing 2 numbers in different units. A unit rate is cost of 1, and then cross products is product of the numbers by the diagonal. I'm just going to draw an example. Okay, if you have 6 over 5 equals 12 over 10, a cross product is just multiplying across like that. Okay, and those are the 4 vocabulary words that go with this section of notes. Now, first things first, 3 ways to write a ratio. I've noticed on your bell work that a lot of you will use the different ways. Okay, for example, if our ratio is 3 to 5, okay, let's say you have 3 stars and 5 triangles. Okay, a ratio is comparing these 2. So if I say what's the ratio of stars to triangles, the answer is 3 to 5. The 3 ways you can write this is like this. First one is 3 to 5. And then I have seen 3 to 5 where they actually use words. And then you can write it as a fraction, 3 to 5. All of these are correct, but for this purpose, this one is my favorite. And that's the one we are going to use the most. Fractions are just something that we have become familiar with, we're used to using, and it's something that we use more often and more easily. So we're going to try and keep them as fractions. And so although in your bell work I've seen people prefer these 2 ways, especially this first one, I want you to start getting to the habit of writing it as a fraction, 3 over 5. There are 3 stars to 5 triangles. That is your ratio. Okay, and then you're going to see 3 different words that mean to divide. And that's the key. These words mean to divide. And anytime you see them, you know it's wanting you to divide. And the 3 different ways, you have each. So if it says each of these, you're going to be dividing them. Each, per, especially if it says per unit or per one. Okay, it means to divide. And the last one is unit rate. The unit rate is telling you to divide. All of these are signs that you need to divide. And so as we're getting into this, you need to make sure you pay close attention to that. Now, next, here's a little hint. If you are looking for the better buy, I have said this so many times. money always goes first. Okay, that's so important. Let me underline that. If you are looking for the better buy, money always goes first. It'll make your life so much easier knowing that. So now when we're talking about setting up and solving for ratio and rates, there are a few different steps. Down here, we have 4 steps, 3 steps, and the 4th is your practice. So we have 3 steps, and then we have some examples up here. And so the first step, step number 1, is to set up a ratio in fraction form for each item. So for each item, we're setting up our ratio. Here's your ratios. And a ratio, remember, is just comparing 2 things, like stars and triangles. It's just a comparison. And so in this case, we're just comparing 2 new things. And we want to set it up as a fraction. So as we go over these, that's going to be the first thing we do. 3 cans of tennis balls cost $11.49. So if you remember, money always goes first. And so we're going to have 11.49 divided by 3. 6 cans of tennis balls for $16.79. $16.79 divided by 6. 9 cans of tennis balls for $22.99. And our goal is to figure out which one is the best buy. I know sometimes it's hard because you don't know. You see this at different stores a lot. For example, when you go to Costco, where you buy bulk. Let's say you get all of these water bottles for this price, and you go to Walmart and you can buy, I don't know, maybe 4 water bottles for this price. Which is really the better buy? Going to Costco and buying the huge 44 water bottles, or going to Walmart and buying the 4? Okay? And the way you know that is how much are you paying per water bottle? Here it's a similar thing, except for it's tennis balls. Okay? Let's say you go to 3 different stores, and these are the 3 different deals they offer. Okay? So think of some sporting goods stores that have the different tennis balls, and each one of these is a different store. And this is the deals they're selling. And you're trying to figure out, hey, which one's actually cheaper? That's how you can use this in real life. Okay, so now that we've set up our problem, step 2 is to put it into the calculator as a division problem. Okay, we're setting this up as a division problem. Okay, I have a little space. I'll put a little divide sign there. And so now, let me move my keyboard so I have a little bit of space so you can actually see. Let me put my calculator right there. Perfect. So we have 11.49 divided by 3, and we get $3.83. And then we have 16.79 divided by 6, $2 and I'm going to round it up to 80. Because really, it wouldn't be 79. You'd have to round the 9, so it would just make this 80. $2.80. And then we have 22.99 divided by 9. $2.55. And now we know the price of each individual ball. And so the last step is to write the answer using a label. You always have to label this. What are you talking about? So for example, if you have $3.83, it's per ball. That's how much you're spending per ball. If you were using my Walmart example and the Costco example, it might have been per water bottle. Okay, it might have been what's the price per water bottle. It could be true for a lot of different things. So now, down here we have our together and practice, and we're going to practice doing just the same thing. Really, the work isn't very difficult, but the understanding is what really matters. So I sure hope you're listening. That being said, if you are listening right now, will you just draw a little smiley face in the top right corner right here? Okay, just draw a little smiley face right there, and then I'll know you're listening. I'm not going to do it because then if you saw it, everyone would do it, so this way I'll just get to see who's actually listening. Okay, in 4, we're going to do these ones as practice problems. Okay, so together, we're going to do 4 together, and you're going to do 4 by yourself. So our together problems, let me zoom in a little bit more for this part. That's a little better, huh? Let me refocus it. Perfect. Isn't this new camera great? Okay, our goal is to find the unit rate. And if you remember, our unit rate is the cost of 1. And unit rate means to divide. So we're finding the unit rate. So for our first one, we go 180 miles in 3 hours. And so when you're doing this, another way of writing this is miles per hour. And so it's clear that miles are going to go first. 180 divided by 3. And then you're going to put it in your calculator. We're going 60 miles per hour. Remember, you have got to label it. You cannot leave things unlabeled because 60 means nothing to me. You're going 60 miles per hour. Next, if you spend $9.60 for 4 pounds, how much are you spending per pound? We're looking for the unit rate, the cost of 1. So how much is it just for 1 pound? And you figure that out by doing 960 divided by 4. Money always goes first. So we have 960 divided by 4. You're spending $2.40 per pound. Also, if you notice, I got just a 2.4, but $2.4 doesn't make sense. It's $2.40. So make sure that you're writing this realistically. The thing with rates and ratios are it's super realistic. It's something you'll be using in your everyday life. This is really something you will use. And so you need to act like it. Next, number 3. If you go 21 3/4 meters in 2.5 hours, how far, or what is your meters per hour? Okay, you're looking for meters per hour, which means your meters needs to go first. And so you have 21 3/4. Man, it really is kind of hard when I write with my left hand, huh? Someone told me to try writing it with my other hand. Yeah, right. Divided by hours, which is 2.5. I would just plug those in. If you don't remember how to do a mixed number, it's second fraction. Your second fraction, it's 21 3/4 divided by another mixed number, 2 1/2. Okay, 87 over 10. You can also change that 8.7. I mean, you could leave it 87 over 10, but remember what we talked about with realistic, how this is something that we are going to be using in our life. You wouldn't say, oh, I go 87 over 10 meters per hour. That makes no sense. You would say I go about 8.7 meters per hour. And so your answer would be 8.7 meters per hour. Huh? Looks like miles, but it's not. It's meters. I just don't have the space to write it out. 4. It costs $68 for 6 square feet of flooring. How much does it cost for 12 square feet of flooring? So first of all, how much does it cost for 1? Let's find out. If we spend $68 for 16 of these, money goes on top. 68 divided by 16, we're spending $4.25 for just one of them. For just one. Okay, so if you spend that on one, then all you have to do is times it by 12. Which gives you a total of $51. Alright, so now you have 4 problems left to do on your own, and then I will be checking those, and we will start getting stamped. Good luck.